So today we are going to cover the rate limiter service. Let's see how we can design the rate limiter service by using the design patterns and different types of algorithm. So let's first try to understand what is rate limiter. Okay. So as you guys can see in this picture, so let's say in the left hand we are having the client, and in the right hand we are having a kind of an entire service which is having two things. One is this rate limiter, and other one is your API server. Let's say as a client, let's say you are trying to fetch the users from the GitHub API. Now, let's say within 1 second, you have made 10 requests, 1,000 requests. So this is kind of abusing the servers of the GitHub. Let's say not just you, let's say there are millions of developers. Now, if they start making very high calls within a second, definitely the GitHub servers can go down. So that's why there are always a limitation on every API that how many times you can call that API within 1 second or maybe within 2 seconds, within 5 minutes. So that is what we call the rate limiter. It works like as a filter. So let's say it will only allow 5 requests per second to reach to the actual API servers, as you can see in this picture. For all the other calls which happen within that 1 second, if they are above more than the 5 calls, then it will not pass to the second stage, which is the API server. So all of those calls will be blocked. Now the rate limiter can be on many bases. It can be IP addresses, it can be your user token, or it can be the location. It can be multiple things. Most of the time, it's more going to be like either IP addresses or the number of time a user can make a call. As a like, let's say you logged in into a Facebook, for example. So you would see that you cannot make various, let's say, hundreds of posts within 1 second. You will actually automatically start seeing a pop-up that hey, you cannot make so many posts within 1 second. So the rate limiter can be based on various things, not just IP address or not just the IP address, but it can be user access tokens or some other things also. The main purpose is to block the excessive calls if the rate at which the calls are coming is very high. Okay. Now let's see what other features which we have discussed in this block. So one is the configurable limit, ability to set the request limits per unit of time. So we should be able to set the configuration. For example, tomorrow, let's say if we want to allow users to have the higher number of requests per second, per minute, or whatever, we should be able to change it. Support for different types of window. Um, so it's more about how you're going to implement your window. Like, I mean, how are you going to say that, hey, the number of requests is will be should be not should not go more than five in every hour or in every last 1 hour. So, for example, let's say let we just go here. Let's say this is how our time clock is. One, two, three, 4, 5, and 6. Either you can say, hey, either we can keep it divided. Hey, from 1 to 3, the request should not go up more than 5. If it goes above 5, then definitely rate limiter will start blocking your calls. That can be one of the way, like you are dividing something like this. Then 4 to 6 or something like that. Or you can say that, hey, in last window, let's say you made a call at 6th. Okay, so window which we will try to check will be this one, which is going to be, let's say, 4 to 6. Sorry. So the window will be just 1 second, 4 to 6. Now this is coming within this 6 one. This is fine now. Let's take another example, which is let's say now 7. Okay, so you made a call at 7 second. Okay, now let me add more things here. 7, 8, 9. Now, either this call which you have made at 7 second can be considered in the 7 to 9 window, or it can be considered in the 5 to 7 window. So basically, how you're considering the window? Are you saying that, hey, check the last window like you do in the sliding window, or you have already divided the window in some partition? You just want to check whether it is correct. It is fine for 7 to 9. You're not checking whether it is fine from 5 to 7 if you keep sliding window. Okay, so basically, let's not go more into this. So this is what this means basically, like how you are going to support the different time windows as we have discussed. Now let's come to the thread safety. So we need to make ensure that rate limiter can handle the concurrent access correctly. Okay. The next thing is ease of configuration. So as we have already discussed, we can have different type of windows or the configuration limit. So the user, sorry, in the service, setting these configuration should be very easy. It should not require, like I would say, specific code changes. We should have a kind of a configuration class or something like that to make sure that they are easily configurable. Other thing is allow the extension for different rate limiting strategies. So we can introduce this rate limiting based on various algorithm, like leaky bucket, sliding window, which we will see how many in how many ways we can do this rate limiting. The other thing is provide metrics and the logging for the monitoring purpose. Okay, so now let's see how we can design it. Okay. So in this one, we have kind of used these patterns to design the entire rate limiting service. As you can see, for this one, extensibility allow the extension for different rate limiting strategies. So what we are saying is, hey, we can do this calculation whether the request is above the rate above the rate or not. As you know, there can be multiple algorithms by which we can calculate that. Okay, so that's why we are using kind of a strategy pattern here. See, that's one. So allows for the flexibility in changing the rate limiting algorithms without modifying the client code. So let's say if we got the request, now we can decide on what basis we want to find out basically what algorithm we want to use to find out whether the request is going above the rate or not. Okay, so now next we are using is the singleton pattern to make sure that we are only having a one instance of the rate limiter. So why we are doing this? So what if, for example, let's say if we are having a multiple rate limiter class and the requests are kind of getting divided into each of them. Now we don't know, like request can go to any rate limiter instance. Until unless we stick them. Let's say if we are not having a sticky sessions and the request can go to any rate limiter class, then it will be a problem. Okay, for example here, the request is only always going to one rate limiter. What if we have multiple rate limiter? One request goes to the first one, another request goes to the second one. There is no way we can count it. I mean, we can count it, but we will have to go to then the HLD part. We can where we can discuss how we can handle it. But for now, we are having the singleton class where every request will go through that one instance of the. Basically, we are centralizing the entire system now. Every request will go through the one rate limiter, so that rate limiter know how many requests a client or a IP address or a user have made. The next is thing is this one. Basically, we are having the factory pattern to encapsulate the creation logic for different rate limiting strategies. That I will show you in the code how we are actually using the factory pattern in this rate limiter. The next one is template method pattern provide a standard process for rate limiting. Okay, so let's say what if I say that this rate limiter is used as a service and you're working in a company where there can be multiple services which requires a rate limiter. So are you going to specifically write the rate limiter for every service? No. So what this template method pattern is going to help us is that we can customize, we can provide our own class of logic, our own logic in a way of class where we can say, hey, allow the request if these conditions are satisfied. We will understand this more further, like how we are actually using it. Okay, so this is what we have actually used here. So regarding the algorithm which we were going to discuss, for now we are discussing these fixed window algorithm, which will be again used for counting the request in the fixed time window. Another one which we are using is this sliding window algorithm for which use the rolling time window to count the request. There are more like leaky bucket and all those things. I would add those algorithms to this block. And let's now come to the code part, how we have coded. Okay. Yeah. So here, if you see, this is the rate limiter factory class which we have discussed. Okay, we will see it in the code how we are actually using it. So this is our rate limiter manager where we are using the singleton pattern. So if you see this association, if you find in any of the block diagram on this platform where the request is it is associating itself to kind of a recursive class where it is associating the class to itself, that means they are most probably using the singleton pattern there. For example, in this rate limiter manager, this is using the singleton pattern to provide us a class for the rate limiter, which we are actually using to handle the entire logic. Okay. Now, under this rate limiter, as you can see, we have implemented two types of strategies which we can use to allow the request to pass or not. One is this fixed window rate limiter, another one is the sliding window rate limiter. The only difference between each of these classes is going to be the how they are calculating whether the request should be passed or not. Okay. And this third class, which is this abstract rate limiter class, which we are going to understand, it belongs to basically this one, the template method pattern, where we are providing a standard process to anyone whosoever want to use this service so they can create their own class and tell us on what basis they want to allow the request basically. Okay, as you can see, I have even implemented some of them, like one of them is both of them, fixed window rate limiter, another one is this sliding window rate limiter. Okay, now let's see the code actually. So this is basically our interface class, which we have created. It only have one function, which is this allow the request. Now let's see the other one, which is this manager. Okay. So if you see here, we have used the singleton pattern, as you can clearly see with this one. We are having this get instance function, and we are using the double locking here, as you can see. Okay, we are using the double locking mechanism here to make sure that even in the multi-threading system it works fine basically. Okay, so we are always going to have only one instance even if this works in the multi-threading system. And what it is doing is it's only providing us basically instance of this class. For by default we are creating the rate limiter with this way. So let's come to the rate factory pattern first. Okay, here this is how a factory class look like. This factory class is used to create a different types of rate limiter. Like, hey, do we want to have rate limiter which is going to use the fixed algorithm like we have discussed here, these fixed window algorithm, or are we going to have a rate limiter which will be using the sliding window algorithm? Okay, and what can be the max request which they can handle? Like, what should be the max requests which we are allowing to the users, which they can have within what milliseconds? Like, for example, we are trying to say, hey, users can only have five requests in this milliseconds. So that for that thing, if we want to have a different types of rate limiter with different configuration that we can do, that we can create here basically. Here for now, if you see this create rate limiter pattern, sorry, method, here you can just pass the type and make request and window thing. Based on that, you will get the rate limiter instance based on your configuration which you want. Now let's go back to the rate limiter manager here. So if you see here, for now we are using this fixed, which allows this 100 request per second, per 6 seconds, something like that. Okay, so this is what we have kind of we have created that class by using this factory pattern here. There's nothing much here, it is just a simple singleton pattern, and where we are creating this kind of rate limiter, we are instantiating that this kind of a rate limiter, which is going to use the fixed window algorithm, and it will allow the 100 requests to enter within the 6 seconds. Okay, now let's see the other class. Let's see this fixed window rate limiter. So as we have discussed, we are going to use a strategy pattern, that is where we are using it. So this, we are implementing this rate limiter. In the rate limiter, if you see, we are having this allow request. Both the classes, this sliding window, this fixed window, and this sliding window, both are implementing this rate limiter. So we are using a strategy pattern here to have a different type of strategy that, hey, how we want to allow, I mean, on what, how we are going to do the calculation, whether the user should be allowed or not. Okay. So that is what we are doing. So here, if you see, we are instantiating this class with the max request and this window size milliseconds, which we have done in this manager. So this manager calls this factory pattern based on what algorithm you are going to use. This factory pattern create the instance of that class. For example, we use the fix, so it create an instance of this fix window rate limiter class by providing that class that, hey, this is the max request and this is the millisecond which we are required for this rate limiter. Okay. So in this instantiation, we are just setting those things basically. And for the fixed rate limiter, we are using these data structures to count to keep the count of the request basically. This is basically, as the name says, we are like keeping the count of the string, and this one is as for handling the window starting time and end time. Okay, so this is just a normal algorithm. There's nothing as such in terms of design here. Just a simple like DAC algo thing which we normally do. We are getting a client ID, and based on the client ID, we are deciding whether that client should be allowed or not. So here, yeah, yeah, here we currently got the current timing from this current time millisecond. There is one more thing which you always need to make sure that whenever you are writing the code, keep the time zone in within one format. Like either you use the UTC or whatever. Like for example, when the request is coming up from the user side, their time zone can be different, and your server's time zone most probably it will be in UTC. So make sure whenever you are playing with the times, you always convert them into your single time zone. Most probably we normally use the UTC time zone. So make sure you are actually using doing that part while you are playing with the time or wherever you are doing any time calculation, because that really matters. Okay, so basically in this class, we are just calculating whether we need to allow that request or not based on this algorithm. It's a simple algorithm. You guys can easily cover it. So I'm not going into the DSL go part here. The next thing is the sliding window. Okay. So in this sliding window, again the same thing. There is nothing much different if you see this factory pattern here. If you want the fixed window based rate limiter, then you just use this class. Otherwise, you're using this class, and all the other things remain same, except you are like based on different logic. Now you are calculating whether the request should be allowed or not, as we have discussed previously, the window and the rolling part. Okay, so this is what they are doing here. Now let's come to the more interesting part, which is this abstract rate limiter thing. So here, if you see, we have created another class, again implementing the rate limiter, but this is an abstract class. Okay. Here, if you see, three functions basically. Sorry, we have two functions. One is this allow request. Okay. And another one is this one, which is request allow. So by using this class, if anyone is extending this class, he or she must implement this pattern. Sorry, must implement this request basically. But it says is request allowed. By using this class, the client, when I say client, the client is who is using your service in their package. It can be anyone. Let's say in your company you are having 5 different services. Definitely, you are not going to create the rate limiter differently for every service. You will just create one and making sure that it is configurable to any service. So now, let's say if I want to use this rate limiter, but I want to have my own logic on which basis I want to say that, hey, the request should be allowed on my logic, not your default logic, your rate limiter, your fixed window, whatever window you are using, whatever algorithm you are using. I don't give a shit to that. I want to be the one who needs to decide whether the request is allowed or not. So how you will do it? You will just implement this class, which is abstract rate limiter, and you will have to um, implement this method. Okay, and you will just return true or false, and based on that, we will allow the request to be passed for your service. For example, let's say we have created this one. If you see this one, so this one here, if you see, we are only implementing the is request allowed thing. Now, as a client of our service, not the users who are actually walking the call. When I say client, here now the client means the those person who are actually using your service to use the rate limiter in their service. Now they can themselves decide on what basis they want to allow the user or not. So it's now the responsibility does not is not in on the rate limiter service. Like, hey, we are having our own algorithm, like we have discussed, fixed window rate limiter, sliding window rate limiter. No, now the person who is using our service to include the rate limiter into their service, they are implementing the method and tell us that, hey, this is how I want to use the class. And now we don't need they will just implement this method, and they're just going to use it. Now you may say like, hey, how it is actually working? So if you clearly see our rate limiter class of our actual service, the main service, the rate limiter service is only having the allow request. So we are not giving the access of this allow request to those clients who are trying to use our service to include into their service. No, we are not doing that. So if you see here this is our internal classes. Okay, here we just directly implemented the allow request. This is again an internal class where we are again did that part. But here in this in this abstract class, what we did is we implemented the allow request by ourselves so that we control the narrative, we control the flow, how the request is going to go through. What we have done is we have only provided the extensibility to the client that, hey, you want to have your own logic, so implement this method. Okay, our flow will actually take it. So if you see allow request, still they cannot implement the allow request. Okay, they cannot. But what we are doing is, hey, implement this is request allowed and return us that true or false, and based on that we will do what you want. Okay, that's how we are making sure that the entire flow is still controlled by us. The entire rate limiter architecture is still controlled by us, but we are only giving them, the users, the extensibility, the client who are actually trying to use the rate limiter to save their service, that, hey, you are having this thing where you decide whether the request needs to be passed or not. Everything else is going to remain same, how the entire flow works. They cannot change anything in the in our flow, because we have created another function, just separate function for them, which they can implement. So they cannot disturb any existing service. So okay. So if you see in the fixed, this is just a sample. I'm not saying that, hey, why we are creating fixed window rate, why they can already use our internal thing. This is just for an example sake. I have created this class, just to show you how to actually implement it. So if you see, allow request is not implemented here. No, this function will be automatically called by this abstract rate limiter method. And yeah, and done. Based on your true and false, basically rate limiter service will decide whether to allow that request or not. Similarly, again, how you can implement another class is not a much difference. Okay, so this is how the actually entire rate limiter service is working. Now let's come to the main class, how we can actually use it. Okay, so uh, here this is how we are actually using it. So again, the way I showed you, here we are bypassing that rate limiter manager. Actually, we are not using that. Otherwise, most probably you will just call this rate limiter manager, okay, and it will provide you one instance. But just for the sake of the example, this is how you can call the factory pattern directly and have a different types of rate limiter. One based on the fixed, another based on the sliding window. And here, if you see, this is how it works. So here we are just this is kind of a testing we are doing to show you how it is, like whether it is working or not. We are calling this functions 12 times, which is this fixed window rate limiter basic, and another class again the same thing with the client too. So here you can see the result that One, two, three, four, five, six, seven. So the seven requests were allowed, but other two were dropped. Sorry, not the seven. Sorry, not the seven. 10 requests was allowed. Okay. So we called this rate limiter 12 times. 10 were allowed and two were not. So if you see, yeah, two got false because we have set that limit here that hey, if you are getting if you are getting more than 10 requests per 6 seconds, then you will definitely not allow those. Similarly, we are testing the same thing with this sliding window. Okay, let me see if we have missed anything here. Um, no, actually, we have covered. So there are more things which we can improve in this rate limiter. Okay, I think I have mentioned it in the big in the that. For example, if we want to change the limits dynamically, so currently you cannot change the limits in between of the service. Like you can't say, hey, from now on I want to have the more than 10 requests. So here, if you see, once you initialize it, you get an instance of the fixed rate limiter. Now, if you want to set a new limit, you will have to create a new instance of this fixed rate window rate limiter. That means you are kind of restarting your service from that one. So there may be a chance that you may get a ton of a load from the API from the users, and those requests may not be filtered by the rate limiter correctly because all the data which is held by this instantiation will be lost until unless you do the uh, you do the net migration correctly. But that is like a very tricky process. You will have to change the code and all that thing. So we need to make sure that that we are allowed to change the limits in the runtime dynamically. Like anytime, for example, if I after 1 minute I think that hey, I will need to change it, there should be a way here basically. So that just call a function, it will be changed without losing any existing data or without creating any new institution, which we are covering in our premium course. Okay. There are some more issues in this rate limiter. Okay, one is the lack of persistence. What if the server fails? Okay, for now we are just talking about one server. We are not talking about the distributed servers. What if that single server fails and it restarts? Again, we are going to lose everything. There is no way of saving this data anywhere if there is a chance that the service may goes down. Okay, there's a lack of persistence basically. Again, as we have discussed that everything is centralized by the rate limiter manager, so there is always a single point of failure which we are having in this service. That is also we have covered all these things which we are discussing now in our premium course. Okay, so again, the scalability issue is that this current design is more suited for the single threaded. We need to have more. For example, this current code will not work in the distributed system where we are having multiple servers. As I have even mentioned in the beginning, this is not for the distributed system because we are having a centralized system right now. I mean, for example, if the request goes to the different servers, then there is no way we can calculate it correctly unless we add some more components to it. Again, right now we are not having a control at a granular level. Okay, what if we want to have the rate limiting different for different client? Right now we cannot do it. We are just saying that hey, every client will have a same rate limit for our APIs. What if? But normally it does not happen that way. For example, if someone have paid more, then you will allow to have to you will allow them to have more requests per minute. But currently we are not having that level of um, granular, I would say, access to the APIs. I mean, granular control. We don't have the service does not provide that much level of the granular control where you can control even based on the per client, maybe per request, or maybe per service it can be. Okay, so that is again we need to add on. There are other things also like using regarding the performance overhead when you're using these synchronized things blocks or like as you know whenever you are using synchronized blocks you are saying that hey, the only one thread is allowed to enter into that block, so there may be a chance that it may add some performance overhead. So that is also which we need to kind of work on. Yeah, so as I discussed, even that here only we are only using fixed window and sliding window here. Other strategies like token bucket and leaky bucket, which might be more suitable. By the way, these two which we are talking about is more suitable for like more advanced system, you would say, like maybe multi-threading or distributed. There you would see these strategies more will work more. At least whenever we are having the multi-threading system, this strategy will be much more better because the way they calculate goes really good with the multi-threading just things. So that is also again we are covering in the course. So again, there is no support for the burst traffic if there is a huge spike. Um, Again, occasional spike when it comes, though we are not definitely supporting that also in this one. Same thing about the dynamic updates. As I mentioned, for now till now we have not added any monitoring in the logging here. Yeah, one more part is like very granular things. We are using the hash map and linked list to store the request counts and the timestamps, but they are not really good for the multi-threading systems. If we use pick this entire code and put it into the multi-threading system, it will kind of block. It will be destroyed because the hash maps are not locked, the linked lists are not locked. So we definitely need to even change the data structures, the way we are not the way we are calculating, but the way the data structures which we are using to do the entire calculation needs to be also changed. This will not work in the multi-threading, and there are definitely the potential memory leaks also if we are not properly cleaning this hash map and linked list query, and which we are actually not doing in our code. So all of these things we are already covering in our premium course. Okay. For these extra things, the videos soon I will add the video in the course itself. Let me check if there is anything we have left. As far as I know, I don't think so. Okay. Yeah, I think we have covered everything now. Yeah, make sure you guys you go through it once, and if you face any issue, just let me know in the comments. What we can improve.